Hello guys, you are probably familiar with this WYZE Sense thingy because I already reviewed it, but I did not do Teardown. So finally I got myself a kit which actually contains all these devices, and this is my own. Now I can do whatever I want. So, and this is brand new, I never actually had a chance to play with it. So just open it up quickly. No kind of weird unboxing because it's all done. It's just like, you know, take it all out real quick, and here we are. So just quick reminder, what are we gonna have here? So we're gonna have a bridge. This plugins in the back of your, look at this magnets here, of your WYZE cam, and it's gonna serve as an access point for all of these sensors. Alright, so we have to take a look what's inside here. Number two, we have two contact sensors. They're two identical, so you can use them as the sensors to check if something open close. They contain magnets, hence they are stick together. And there is a reed switch, highly likely, which make this clang noise here. So we're gonna put them separately. Oh my god, this is really annoying. They still, oh my god, that's really, I'm gonna put them further away from each other, right there. So then we also have this motion sensor, which consists of pure sensor of some sort and some electronics. So all of those three devices got talking to this guy. I'm also curious what's the maximum number of devices can talk to this one. I have only 3, but curious if you can say, you know, set up like 16, I don't know. What's the top number for devices supported by this device? Obviously have setup guide, which I was already covered in my previous video. I'm gonna include link, and we have little pokey bits to actually reset and turn these devices into the gonna poke this into the connection mode of some sort, so we don't need this now. So today we're gonna go with Teardown. So one of those dudes I'm gonna put aside because I'm gonna be touching, so go here. So let's start with the bridge. So put this to the side. So bridge has USB. It has a button over here. I guess that's just for reset the thing. It has MAC address, but some sort of weird MAC address, not enough numbers. It's like one digit is missing. Weird. Curious, I don't know if you see that. Let me find some kind of pokey thingy. Yeah, rather. Okay, so here's the MAC address, VCID and la la la. So this thing is clearly glued, but it's never stopped us to ungluing things like that. So for process of ungluing, we're gonna take X-Acto knife, looks like, and we're gonna just go over with X-Acto knife just like this, just to make sure there is no glue. Just break down any glue, and it looks like something is already cracking, so it's a good sign. Yeah, hilarious, I already broke the shitty X-Acto knife. Whatever. Let's run it on this side as well. If it takes too long, I'm gonna do it off camera, just to wanna bore you guys. Also, alright, and we are in. After using this heavy duty like leverage spudger, I was able to kind of leverage it out of there. So we have a backside of the PCB here, which clearly has this antenna thing. This mylar probably film protects it. What kind of fabric over here? Protects it from this, I guess, metal thingy here, just to make sure it's not gonna short. I guess they put some mylar film over here. And the chip of some sort, and we're gonna take a look what is that. And here is probably LED. Let's push this out. It slowly goes. So out of USB. Oh yeah, just like that. Ta-da! So there is nothing really here. So this is backplate, this is the. So on this side we have Okay, let's use some magnification here and see what we have. As I mentioned already, I'm quite familiar with this dude, sorry, not with this particular dude, was the series of chips from Texas Instruments. This is Simple Link device, one of their many, actually. There is a big group of devices and they called Simple Link, and one of them I was playing with, that's Bluetooth 4LE device which support multiple protocols, multiple RF protocols. But this particular one is ultra low power, sub 1 gigahertz RF device. So this one doesn't support Bluetooth 4LE, but this garbage bothers me here. But it's quite as powerful as the other one. So this, it has Cortex M4 inside, ultra low power, up to 48 megahertz, but it's obviously it's controllable, the frequency, CPU frequency. So but the most important thing, this is a RF device, so it can transmit, it receive RF signals, and it supports specific protocols. I could not find much of information on this particular unit, what kind of protocols it supports, because obviously it's not Bluetooth 4LE for the given reasons. Plus also Bluetooth 4LE won't be able to work over some distances and obstacles, so it needs sub gigahertz device. So I will include some more information on this particular guy in the link below or in my article on the website, because I need to dig it a little bit more details on what specific protocols will be used between this and slave devices or sensors. So those two thingies over here, there are two, I don't know what are those. I couldn't find information. One says, this one says CE1AH, have no idea, couldn't find much on it. And this one says DK8S, same story. So because this device is super highly integrated, as you see, there is not much peripheral going on here, except probably stuff related to the antenna. Like this is, as you clearly see, all this jazz goes towards antenna, so all this RF frequency, RF device, like RF capacitors and transistors, which require to supplement this circuit. Highly likely those two devices are just some sort of voltage regulators of a sort, but even this guy, it actually has DC to DC inside, so it does not need much. So honestly not sure which are those devices. And the flat black PCB, really hard, it's better than shiny glows, but it's still hard to trace where are those going to. So again, there is just crystal here to drive this dude, and that's pretty much it. And let's take a look on other side, and we see very interesting thingy here. So this device, like we have on this side, we have LED button and this. That's pretty much it. So this device is WCH CH554T. Turned out to be, this is like ultra low cost, low power Chinese microcontroller, and it's nothing really spectacular about it. It's just regular microcontroller, but the great, like in terms of like performance and things like that. But the crazy stuff is that it supports a lot of peripherals. It has SPI, USB host, and USB device and things like that. I didn't really dig into details because that was new for me. Again, I'm gonna link the link to PDF, because whatever I found was in Chinese and I need to dig better. But this is as new as new for me, because I still kind of floating in those Chinese clones or Chinese manufactured purposely built microcontrollers, so I'm not really familiar with them at all. So that was cool to discover. And apparently there is a stuff on GitHub and Hackaday. There's a bunch of people already doing stuff with this microcontroller. But I'm wondering, I thought this device have some sort of USB compatibility in it, but turned out to be, in order to talk to USB right here, you need something like that. So essentially what you have, this guy talking to USB and doing all the jazz, maybe, I don't know, handling buttons, things like that, but this guy actually doing the business in terms of like RF communication. That's what I can derive out of this design, just right like that. So Yeah, looks pretty neat and I love it. Let's open the other guys and take a look at the whole picture. Alright, I'm probably gonna keep this quite high level of zoom here, just not to zoom out every time or switch the lens every time. So this is super pooper simple. I think there is nothing to take a look what's in the magnet section, right? So it's obviously just a magnet. I'm not sure if it's neodymium or how strong is the magnet, but I'm gonna put it over there. And this guy, okay, this guy should be easy to open because it's serviceable, because it has the battery. So battery can be replaced, and battery, this 3 volt tiny Handley Max battery, 1632. And we already see some cool stuff right off the bat here, and it's already getting interesting. The problem is here that this particular one is sort of riveted, so there is a plastic top over here which is like melted, right? And then you need like to pry it open here. So in order not to damage an antenna, what I'm gonna do? Try to just cut off this somehow. Yeah, just like that, maybe. Just cut this plastic tubbing off, and then... oh, it just turned on. And then try to pry it open. Okay, let's try to take the battery away. I just remove the battery, it will give me an access to probably... there is no tops anymore. So lots of white funny things over here, curious what is that supposed to mean. Yeah, so it has only one, so I'm curious why it's not coming out. It is, yes, it's out. And it's so snug there, so I don't really need. Ta-da! Okay, let's remove this stuff away. So what do we have here? Look at how nice and tiny is this. I love it. All right, so this is pretty small and tiny, and just let's take a look what we have here. So again, we have the same suspect, CC1310, which is, I already know, ultra low power simple link device from Texas Instrument. So as you see, this is exactly the same dude as we have on this board. So they are, you know, friends, they are talking together. This guy probably just configured to send command. Maybe they bidirectional. Yeah, I need still like that's the only thing I have to figure out. They have to be bidirectional because it looks like they can send commands back here. But let's take a look at other things. So over here we have only passives, whole bunch of passive devices. A crystal, a button, and the read switch, and that's it. The button is probably the reset button to actually turn it into the pairing mode of some sort. Discovery mode, this antenna, and the very similar like circuit for the antenna, familiar ref circuit, like as similar as over here. It's not the same layout obviously, but they're roughly the same amount of devices, so it's pretty much identical circuit but different layout. There is no power regulation because this dude just takes straight the power from here, and it has DC-DC converter inside, so converter or regulator is inside, so just completely self-sufficient in this regard. And that's pretty much it. And it has to have like little tiny LED somewhere, which I don't really see. Well, okay, let me kind of, yes, so over here, so this is the hole, so this is that tiny LED over here. On the other side, on the back side, you still see the antenna, and that's pretty much it. So battery goes in here just like that and keeps this little dude powered. So, and how it works, for some people probably pretty obvious, but just want to illustrate. So when this thing is powered and it's in lock state, I don't hear the click of the read switch actually. Weird. Usually it's noticeable, but not in this particular case. Whatever. So reed switch will engage two contacts, like just like this. You see, you can actually see those two contacts right here, and when they engage, this thing gonna well, sorry, when they are disengaged, it's gonna trigger the alarm. So it's like, if it's disengaged, it can trigger the alarm, because switch is gonna be disconnected. The poles of the contact will be disconnected, and it's gonna trigger the alarm. But technically, it doesn't matter. You can put the opposite. Curious if you can put the opposite, trigger the alarm when it's closed. For example, if something and someone closed something which is not supposed to be closed. So that's curious if you can do that. So here we are. So this is the very basic construction of the what's the name of this particular sensor? Contact sensor. Yes, it's called contact sensor. We don't say the reed switch sensor, but this is the construction of contact sensor from WYZE. Nice and tiny. Next up is the motion sensor. Let's take it open. I don't know how it's, where's the, alright, it just opens just like this. It's opened. Yeah, it has this dome, which is the lens for the motion sensor, a little button over here in order to put it in a pairing mode, and the LED hole. So it should be easy to open as well, because this thing is serviceable. This, oh wow. Okay, that's a bit of a difference. Take a look at the tiny battery. Like, let me compare and pull this guy out, because it looks like I would need to. Oh my god, this is kick-ass battery. Whoa, I never actually seen those sold somewhere else. Okay. Yeah, check the difference. So obviously this dude has to do way more work than the other one, because the other one is just on and off, and this is probably gonna trigger way more often. So hence the huge battery over here, probably like 2 times or 3 times bigger the capacity. Alright, this is gonna be even a bit more trickier to open, because take a look at that. It has the little thingy over there, like just, you know, and then here it is. And I have to peel this and even more, they actually decided to glue it with some elastic over here, so that has to be cut off as well. So we're gonna start cutting off this part right there. Like, have to make sure you're not gonna cut something really useful, because happened to be once 2 different devices try to chop it off, and it's turned out to be required to be there. Okay, this kind of comes out. Well, there is more elastic on the other side. I'm not sure what I'm pulling. Looks like I understand what's happening here. Let's cut this a little bit more and just yank it, but nicely. Oh, maybe not a good idea. Oh, I see what's happening. Looks like they have a wire going to the antenna, and I don't want to ruin that. And it's just a metal thing, not the wire. Antenna is glued. To me, I want to do minimal damage here, so I want to just maybe I will unsolder it or something. Well, it's really hard. Maybe I would rather go this way. Okay, let's remove as much as possible of this goop. Maybe I actually cut this out as well of the video, because it's huge. It's a lot of time. Alright, we are in. So they were pretty smart people, and now it knew that me as a curious person going to be disassembling. I thought actually this is the metal wire or metal some kind of top which goes and connects to the antenna, but no, this is a spring contact. Look at this. So this is the RF antenna. Here's the pad, here is the whole business end, and here is the metal contact, which actually, hence now I understand why all this goop is there, because they have to firmly press this contact towards the that top. And here is the lens, which is obviously, we know, usually a quite complex device in order to send RF signals right straight into this little hole. And I explain how motion sensor, pure motion sensor works, and the lens is quite important. It's really hard to see actually in the construction of the lens, but like it has a lot of concentric circles which actually focus infrared right in there. So, but this is pretty much it. The antenna is left behind over here, so we're gonna put it aside and take a look at this. We have here usual suspect, which is our CC 1310 simple link device from Texas Instrument. Then we have, as obviously, because this is motion sensor, this is pure sensor, and this particular one is WYZE, which is very simple pure device. It's not like it's all in, which contains like active circuits inside. This is just pretty simple device which detects, and then you have to have the chip which actually handles that signal from the device. So, and this dude is some sort of RS8034, which I couldn't find information on it, but because this is simple device essentially, which require some sort of the chip which actually process information from here. So I suspect this is the pure chip, because we do have what's the name of this chip always, like B0001. Let me have my notes here. Open my notes here. I usually record all my info. BISS001. Yes, but this is not it. Unless it's a clone of a sort of the same BIS0001. Yeah, so that's pretty much it. I want to show you something interesting. Take a look at this. So all this pure jazz together with this capacitor is on some sort of razor board. Yeah, and it's all kind of side soldered 1, 2, 3. So it's doesn't have active elements here, but there are some basic components like few capacitors and electrolytic capacitor here. So this pure sensor module, it seems like as an add-on board or daughter board of a sort, which actually just solder it in 3 points over here. And if you turn it upside down, you would see 3 holes, 1, 2, 3. It's probably cutouts to make sure the pins of those devices like capacitor and this guy are actually, there's enough space for them. So this is kind of hilarious to see that it's better to use those component base and use this kind of cutout as a part of a process of PCB making, which is still probably economical enough for them to do. This is actually quite weird. I thought it's easier just to solder freaking this thing right straight in there and Bob's your uncle. But hey, I mean, I don't know. I don't know if it's a bodge or it's a design, but this is kind of interesting to see. Actually, not much happening over here. So again, as you see, the chip has a whole bunch of passives over here for the ref circuit, for the antenna, button, LED over here, this tiny LED right there. And what also I found quite interesting on the back side, there is nothing else but a battery and whole bunch of test points. Those are test points. They even have names on them. That's actually pretty cool. And if I take a look at this one, it's the same pretty much story. Have a whole bunch of test points over here as well, which is nice. All right, let's put them all together over here. So we have 3 devices. Well, we have 2 of these, but one is still assembled. And they are all part of WYZE Sense kit, and this is their host device or gateway, and they all talking to this dude. So we still have to figure out what kind of protocol they're using in order to actually communicate, but that's what's inside. So CC3110 is the heart of this business. Everything else is just just supplementary and peripheral. But yeah, this is what we have. I'm curious, obviously, if you would be able to reprogram this thing, and how we can access and get in. But that's secondary. Hackery is a bit more complicated usually, and in order to do that, you have to have something in mind, particular like. But otherwise, I will try to use them as is. So guys, I think this is it for now. I'm gonna obviously share and provide high resolution pictures of all these devices I open for people to analyze and to play with, and technical information I will share as well. Hope you guys like this video, and see ya next time.